We are going to do a little bit more today when it comes to section 5.5. And depending on how quickly we get through things will depend on whether we finish today or not. Okie dokes. All right. So last time we talked about simple interest and compound interest. Today we're going to add the third type of continuously compounding interest. So when we say continuously, what kind of value for K are we talking about? How many compounds per year are we talking about if it's continuously happening? What do you guys think? Who wants to take a risk and just throw out a guess? Number of compounds per year for if we say it's continuously compounding. 3. It's more than 3.
No,
Keep going. Go ahead. More than 365. More than every day. Infinite. Yeah, there you go. Continuously compounding means an infinite number of compounds. So, what is that going to mean for us? Is that our old formula is going to transform into this. So FV, still future value. PV, still present value. R, still interest rate as a percentage. N, still number of years. E is that irrational number that we've talked about before, right? And I forget what the decimal approximation is, like 2.7 or something. Yeah, 2.718 or so. So things that are happening continuously, that are continuously changing or continuously growing, that is going to be done with E. So give me an example of a thing that would be growing exponentially, but the change would be happening continuously, rather than at a fixed time every year, like compound interest. Right? If you looked at your bank account, you get your interest payments like every quarter at the first of the month in that for that quarter or whatever. But lots of things change and grow exponentially that don't happen periodically. The change is happening kind of all the time, at every instant. Think about like populations of organisms, right? Like the number of people in the world is constantly changing. Babies are being born at basically every instant, and people are dying at basically every instant, right? So most like real world things that might be happening exponentially are often kind of continuously changing. All right, let's look at an example, a numeric example to kind of practice using this. It says that Jack invests $800 into a savings account with a 5% annual interest, compounded continuously. So as soon as I see that, I know that I'm going to be needing to use my continuously compounding interest formula. How long will it take for Jack to have $500 in interest? So we have a PV, we have an R. We're asked to solve for N because it says how long. What is our future value going to be? I mean, it's related to this, but what it's not, 500 is not our future value. What would the future value be? It says, how long will it take for Jack to have $500 in interest? So how much did Jack start with? 800. When will he have $500 in interest? How much money will he have if he has $500 in interest? 1,300. So far, so good. Okay. We'll solve for n now. Notice, where is my variable located? In the exponent. How do I solve for a variable in an exponent? I have to use a logarithm. Before I can do that, though, I have to isolate the exponential part. So I'll just start by dividing both sides by 800. I can reduce that. Now we'll take the logarithm of both sides. Which log base should I choose to make this problem as simple as possible? I should choose the base of my logarithm to match the base of my exponential, which is e. So I want to choose log base e, which is also known as the natural log, or when I write it on my paper, I write ln. So we'll do the natural log of both sides. Log base e cancels exponent base e. And then to get the n by itself, we'll just multiply by the reciprocal. So I get about 9.7 years. All right. So one of the things that all of us will eventually have to do in our life is to take out a loan for something, whether it's buying a car or buying a house or paying for college or something, right? Maybe medical care. Any number of things that require us to take out a loan, right? Or could require us to take out a loan. One of the chief concerns in that situation is, how do I choose the best deal when I have like different interest rates and different number of compounds and all of these things? Like, how do I choose which one is the best? So that's what we're going to be talking about here. And the tool that we're going to use to make that decision is called, where did mother there? Is called an APY. This stands for annual percentage yield. And this is takes a situation and converts it to it's basically the conversion of some other term into an annual interest rate. So the APY is basically this interest rate compounded annually. So our formula to calculate an APY is the following. Oops. So 100 times the quantity, 1 plus R over 100K to the K minus 1. And again, these are the same R as interest rate and K as number of compounds. So with this APY, we can answer questions like the following. Which investment is better, one that pays 7.8% compounded quarterly or one that pays 7.65% compounded weekly? So I have one situation where the R is 7.8 and the K is 4. And the second situation where the R is 7.65 and the K is 52. So I'm going to calculate the APY for each of these two situations. And then I'll compare the APYs. And the one with the better APY is the one that I should choose. So there's my first APY, about 8.03. And there's my second APY, about 7.94. So which investment is better? So situation one would be the more profitable choice, right? When it's an investment, you want the bigger percentage. If it's a loan, you want the lower percentage. So the situation matters, right? I think most of us have enough common sense to realize that, but worth pointing out that the situation matters, whether you're borrowing or making. Does everybody feel okay here? And I think, if I recall, it's been a while, but when I was shopping for my mortgage, I think all of the loans are the loan companies are required to report you out your options in terms of APYs. That's not the actual loan you're getting, but they're required to give you the APYs. But this is what it's doing. It's just giving you the equivalent as if this was a compounded annually interest rate. That's all that APY means. Everybody okay? We see how it's useful, right? It allows us to comparison shop much easier. The last finance topic that we're going to talk about is an annuity. And this is just an annuity is a type of account. in which a sequence of payments are made. So what does this sound like? Well, it sounds like your mortgage or your car payment or a loan payment or even an investment like a retirement account, right? Where you save, $100 out of every paycheck or something. Does everybody kind of see what I'm... Okay. So we say that an annuity is ordinary So we say an annuity is an ordinary annuity if the payments are always the same time or always the same size and they occur at the same time in that compounding period. For our purposes, we're going to always say that they're going to happen at the end of the compounding period. So our formula for annuity is the following. Is this. FV is again future value. R is the size of that ordinary payment. I is, or little I here is actually going to equal R over 100K, where the little r and little k are just the interest rate and the number of compounds. We do that just so the formula isn't so obnoxious. And N is the number of ordinary payments. Or in our terms, N times K. So let's do an example here. At the end of each quarter, Sarah makes a $500 payment into an annuity account. if her investment earns 7.88% annual interest, compounded quarterly, what will the value of Sarah's annuity be in 20 years? So I hear the term annuity. So I know I'm going to be doing this. So R is my regular, or $500 is my regular payment. 7.88 is my interest. Each quarter, that's telling me the K is 4. And 20 years later, that tells me my N, or little n, I should say. Everybody good with where I pulled my values from? So I know that little I is R over 100K. And we know that capital N is N times K. So if we fill these in, so 500 times 1 plus 7.88 over 100 times 4 to the 4 times 20 minus 1 over 7.88 over 100 times 4. Now, to get this into my calculator, it's pretty annoying to have these fractions on top of fractions inside of fractions. So what I'm going to do is I'm going to do the 7.88 divided by 100 times 4 first, and then I'm going to use that number rather than typing the fraction in a bunch of times because it's going to just get pretty nasty in my calculator. So I'll do 500 times the fraction. Oops. Gosh dang it. Let's see, we have the fraction, and then it's 1 plus that answer to the 4 times 20 minus 1 over that answer. Oops. Everybody's okay? And at the end of 20 years, Sarah's going to have $95,483.39. That ain't bad. Let's say Sarah was a little younger, though, when she started doing this. And say she was able to do this for 50 years instead of 20 years. Look what happened. Oh, I made a mistake. No, I didn't. Oh, that's why. Yeah, I did. Okay. Okay, stop. I did make a mistake. Do this. And then we'll do that. Okay. Notice what would we call Sarah here? If she did the same investment strategy for 50 years? We'd call Sarah a millionaire. A millionaire. $500 saved 4 times a year at a humble 7.88% interest, like a index fund from, like index fund or mutual fund level return, pretty average, like average to good level return. 50 years later, she is a millionaire. But she needed 50 years to do it. That's why it's important that you guys start saving. Start a mutual fund. Start a savings account. Try to put away, a couple of $1,000s a year every year. And boy, it adds up when you have time on your side. Looking at a room full of potential millionaires, it doesn't take a lot. Just start early and invest. And you can get there. All right. Let's continue. So the other situation which we can think of an annuity is in paying back a loan. So this first one is like the investment. Or you can have like a loan annuity, or think about a loan as an annuity. Where PV is that amount you borrowed So it's, again, the formula's just been rearranged there a little bit. But it's basically just the same formula, just been rearranged a tad. Oh, so fast, Roman. Now let's look at a numeric example here. So it says Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes a $2,000 down payment and the annual interest is 2.9%? Old Maria must have bought this car a little while ago because the interest rate has not been 2.9% for a little bit here. Interest rates are hovering around 7 right now, which is just kills you. All right. So I am not given, well, since I see that this is a loan, I know we're going to be doing the loan annuity. So let's see. We're asking for the monthly payment, so we want to find our R. N is 4. Since we're making monthly payments, we know that the K is 12. And there's my interest rate. Our present value, though, we didn't borrow the price of the car. We paid $2,000 up front and then borrowed the remainder. So our present value is actually going to be $16,500, right? Yes, you may. So if I divide both sides by that thing, I'm going to have this, right? Everybody's okay? Now it's just a matter of getting it into my calculator here. So I'm going to do this in kind of two phases. So I'm going to start by doing that calculation for I, so I don't have to deal about fractions inside of fractions, just like we did before. So then I'm going to do this calculation here. So there's that fraction. And then I'm going to divide. Oh, no, I screwed it up. Gosh dang it. What did I do wrong? Who sees it? I knew I did something wrong because I got a negative value there. I forgot the negative sign. There we go. And then I'm just going to take that number and then divide the 16,500 by that. So my car payment should be about $364.49. Okay, so one more example question, then I'm going to show you some calculator stuff. Using the same information from the previous example and assuming all of Maria's payments are equal, how much does Maria pay over the life of her loan? What Maria paid is going to be $364.49 every month for 4 years. Everybody okay there? I'll just use all my decimals. So she paid $17,500 or $495.41. Did I say 41 cents? Okay. So far, so good. And what did she end up paying in? So that's how much she paid. How much in interest, though, does she pay? Well, she borrowed $16,500. So we ended up paying $995.41. That was essentially the cost of the loan. She ended up paying an extra $1,000 for her car because she had to borrow the money instead of paying for it all up front. But who's got $18,000 laying around? Probably not a lot of us, right? But that's how the banks are making their money. That's why you don't see banks going out of business. Okay. What I want to show you is some calculator stuff. So if you have your graphing calculator with you, I encourage you to take it out and follow along. Your calculator is a built-in app that makes doing these sorts of finance calculations very easy. But you need a little bit of practice on how to use it for you to be able to use it effectively. But all of these problems that we've done by hand, you can do on your calculator. So let's start with this annuity investment problem. So to find the finance app, we're going to press the apps button in the middle. That's the purple apps button. And you're going to pick the finance application. That's the only one on my calculator. And we're going to be using the TVM solver always. So for the TVM solver, we need to supply the following inputs here. So in this problem, it wants the number, N is still that number of payments or the number of investments. So that's 4 investments per year for 20 years. So we'll call that 4 times 20. Notice that I can just type in 4 times 20 and the calculator will do it for me. My interest rate is 7.88%. My present value is 0 because I don't have any money in my account when I start. My regular payments are $500, but I'm going to type that in as negative 500 because it's going out of my pocket somewhere else. Like it's an accounting thing, right? We're looking for the future value. My payments per year, I did 4, and the compounds per year is also 4. So what I want then is to compute this future value. So I'm going to move my cursor so it's back on the future value. I'm going to press alpha and then enter. And there's my same value that I got before. Look at that. It was quite a bit easier getting it into my calculator here than having to type in all the symbols correctly, right? This makes it pretty simple. If, for example, you had done this as positive 500, it just means the future value is now going to be negative. You can kind of just ignore the negative signs when you do this. Like, you know what's happening here. You don't have negative money when you're left. But the calculator thinks about it as like an accounting problem. This is basically saying you're pulling $500 from an account every month. This is how much you would have lost by taking that money out. That's another kind of annuity. Like, people can do like like you can sell your house back to the bank that way and still live in it. Like, that's a thing that retired people sometimes do. It's like an annuity sale on your house where you sell it back to the bank and they give you regular payments for like 20 years or 10 years or whatever. And at the end, that you have to move out. The bank owns your house, but you've collected income the whole time. It's like something that retired people will do on occasion. For the next one, so if we did this, let's see, we had 4-year loan, 12 payments per month, so 4 times 12. Our interest rate was just 2.9. What a steal. The present value, so when we took the loan out, the bank gave us $16,500. So I'm going to make that positive. The future value should be 0, right? We should have paid back the whole of that $16,000 that we borrowed. 12 compounds per year and 12 payments per year. Those are almost always going to be the same. Oops. In fact, I can't think of a reason why they wouldn't be. And then we want the payment. So I move my cursor to the payment. I press alpha and enter. And now that's reporting it as a negative value because where's that money going? Out of my pocket to the bank. Now, when I write this number down, I'm going to write it as positive $364 because there's not like a flow with the question, but the calculator needs to do, like, is doing this as like a flow thing where the negative is indicating the direction that that money is going, whether it's going into your pocket or out of your pocket. Everybody's okay with that? What if we wanted to do like, well, we can't do the E problems with this because it doesn't do the infinity. Mm-hmm. But what if we had like the same kind of problem? Oh, no, let's just go to yesterday. Just go back to yesterday's. Or not yesterday, but you know what I mean, the last classes. So if I wanted to do like this guy, so we invest $2,000, 6% compounded annually after 3 years. So 3 times 1 is my number of compounds. 6 is my interest. My present value is 2,000. I'm not making any payments. My number of compounds per year is 1 and payments per year is 1. And I'm looking for a future value, so alpha, enter. And there is my value, 200. And actually, I probably should have made this one negative and that one, so that one would have come out positive. But like, who cares? It doesn't really matter. You guys kind of see what's going on how to use this app. When it comes test time, I would say it's acceptable to do everything through the finance app. Just write down your inputs. And you can do all of these types of problems through the finance app. Let's look at this one. This is looking for how long. So that's going to be searching for our N. So 6%, $1,000 was our initial. And that time I'm going to write it as a negative since I'm taking my money and putting it somewhere else. It left my pocket. No payments are being made. I'm going to write this as positive 4,000 because it's coming out of the bank into my pocket. And these are 12s. And now if I look for the N, I get 277. but I have to remember to divide that by 12. And there's my 2316. Why am I dividing it by 12? Because the cap n is the number of payments or number of compounds that is happening. So I have to convert that back into a time. Since this was happening monthly, that's why I divided by 12. But again, that's probably way simpler than the algebra that we needed to do here, right? If we did this one, oops. So we have 10 years, compounding every 52 weeks. Here we're solving for the interest rate. We put $600 in. We're not adding anything to it. We want $1,500 to come out. The number of compounds per year and payments per year should be 52. Let's find that interest rate. And there's that 9.17, just like we got before. This is really nice. I encourage you to use this finance app when doing the homeworks. It is okay to do these investment problems or these finance problems on the test using the finance app. That's the way I would do it because, it makes it pretty easy. But you do need to get some practice on it. That's it for me, though. What do you guys think? So at this point, we can now finish up the problem set. Our last problems would be 151 to 184. Again, all these problems at the end, you can do the finance app on. There's not really anything to write down. You know what I mean? You're just going to read it and practice and check them in the back or check them with the answers. I wouldn't do any of them by hand. You don't need to do them by hand. You can do the finance app on them. But that's it for me. So next class will be the review day. You guys will write your half sheets and work on the review problems. This other half a problem set will be due on Sunday. Then we'll be taking the test beginning of next week. What do you guys think? It's all right? Sounds good to you. All right. That's it for me. I'm going to turn off this recording. You guys have 25 minutes or so to just hang out or get started on things.